Hi, my name is Marco Antonio Cortes Marin, and I will show you how to analyze a PID diagram. Let's start with what is a PID. A piping and instrumentation diagram shows the piping and related components of a physical process flow. It's commonly used in the engineering field. This is commonly used in the biotech and the chemical industry. That's why it's very important for us to know it. It's functional because of the maintenance and modification of the process that is graphically represented at the design stage. The diagram also provides the basis of the development of systems control schemes. This diagram basically contains the process equipment, the instruments, the process control strategies, and the most important elements for the units are to define and organize a project, to maintain control during the process, understand how the plant is controlled after the end of the project, keep a record of what has been formally agreed and approved before the construction, and record what was built, the way the design, the PID is. And this is what we can know as a PID, and is also accompanied by a process flow diagram, a PFD, because this can show us a lot of instruments. These are the PID. These are the PID symbols. This is a symbol of a device of instrumentation, and these are the symbols of the PFD. That this is you can find different types of instruments and devices. Like this is a tray column. This is a centrifugation pump. We have centrifugation pumps, motors, heat exchangers like this, and valves. But what is important in the piping and instrumentation are the pipes and the symbols. These symbols are important because there are different kinds, and the most common used are the analyzers that has an A, this has a P that is for pressure, there are L's that are for level, and there are T's of temperature. Here we have another letters like H, like F's, and it has, depending on where are located, are the tasks that are accomplishing. H is like for a hand switch, here is a bulb, and where F is for another task. And here we have an example of a process. This is a part of a process that have all the symbols of what a PID is. Here we start with the circles. As I said, there are the devices that are used in our PID, but when it's in a square, it means that it's a computer screen control that you can see on the screen. There are the letters, as you can see, there are letters on the circles, in the circles, and numbers. The letters means for the kind of device that is, and the numbers are for the tag that we use to recognize it in the PID. This HS means that it's a hand switch that you can change here to automatic to manual this device. Then in the other we have a solenoid bulb that it is marked with this. This is this complete scheme is for a solenoid bulb. Then here we have an XB that is an actuated bulb that are marked. This and this are solenoid are actuated mark. Here is the tag. And then let's explain what is this digital. What are these instrument signals? This is a digital output that are commonly used to know what is the signal going. Here we have the line of the signals. These lines change depending on its figures. As here we can see, this is a mechanical signal that goes into our digital output to convert this mechanical signal to an electrical signal. Then this electrical signal goes to our solenoid bulb to change it to a pneumatic signal. This means that it's a pneumatic signal, and then it goes to a piston that enters to a valve. This valve means that a kind of a flanged connection valve, and it goes to a minor instruments and is connected to other processes. Here we have three different valves. These three valves are with flange connection valves. We have this minor instrument signal, and the most these numbers, these two numbers are the diameter of our connection. There are 2 inches connection, and this is how we analyze our types of PIDs. In conclusion, it is important to know the relevance of the PIDs and the industry and how to interpret them. This is the way the engineers and the people can understand what is happening during the whole process, and it would be easier to find and fix a problem in case of.